square basis. We put another SGZ here because we want to make sure what is exactly the final state of the lower channel. So we can see the final state is purely Z down. This is a quite interesting result because initially we sent Z up here, but finally we got Z down. And when students facing this problem, initially they just don't have an idea about why this happened. Because actually students initially they don't have a good understanding about the operation in the spin space. We have tested the same question in the pretest. We asked students if they send Z up passing through SGX, what would happen? One student says that only one spin state is observed because only one state was sent through. And another student answered that splitting will occur in the x-axis, however, the spin is at Z, which feels no force from the field in X. So from these two answers, which are false answers, we see that students just have a misunderstanding of the difference between the spin space and the position space. So our simulation actually helps the students to understand the operation in the spin space. So before they do the tutorial, in the pretest, they got a score about 55, and after they finish the quiz, the post-test score increased to 76, which is a quite good improvement. So we can say our quiz did help students to understand the circular experiment. I've talked about the quiz, and now I'll talk a little bit about the concept test. As you know, the concept tests are used in the lectures to help students keep up with the instructors and give them an opportunity to clarify their difficulties and topics with their classmates so they could build their own knowledge. And one particular concept test we have designed is for the one-dimensional infinite square wave. Of course, this is also very fundamental, and it is taught in the early stage of the quantum mechanics. Many of the quantum concepts are involved in the 1D infinite square wave. So we have made the concept test with 4 different problems. All of them are multiple choice. And each of the problems tests a particular concept in 1D infinite square wave. They are about the stationary state, time evolution, the position measurement, and a combination of energy eigenstate as time evolution. So for one class, we gave them the concept test during the lecture, and for another class, for the control group, we didn't provide the concept test. And we gave both classes the same post-test to see whether our concept test works for them. Here's the result of our post-test. The red bar represents the control group. So like 3 students got score 0 in the control group in the post-test, and 4 students got score 1 in the control group in the post-test. And the blue bars represent the experiment group. So like 7 students got score 5 in the experiment group who have done the concept test in the lecture. So from this distribution, we can see that the control group has a much better performance, and the experiment group has a much better performance than the control group. So only 1 student in the control group got a score 6, and all the others are below 3. However, for the experiment group who have done the concept test in the lecture, the median is about 5 to 6. And the average score for the experiment group is about 55, and for the control group it's only about 20 out of 100. Through analyzing the students' answers in the post-test, we see that in the control group, students have difficulties when they're understanding a certain concept in the 1D infinite square wave. For example, time evolution. So in the time evolution, in the post-test, we ask them if the initial state is a superposition of 2 stationary states, psi 1 plus psi 2, what would happen after time t? What would be the final state? In the control group, students just have no idea of how to do that, or maybe they don't have a clear idea of how to do that. So some students may just multiply psi 1 plus psi 2 and multiply that by a factor e to the minus I e t over h bar, kind of that. And in the experiment group, nearly most students could correctly finish that part, finish the time evolution part. So we can see actually our in-class concept test just helps the students to learn what is the related concept. For example, the time evolution or the like position measurement in the 1D unit square well. So in summary, our quiz and the concept test are based upon the research on student difficulties, and we use the computer simulation to help the students learn the certain concepts in the certain sections in quantum mechanics. And students could work on the quiz either in class or at home. So actually we have provided a package for them to download and to run it in their computer at home. For the concept test, it is usually given in the lecture, but it could be given like after each concept was addressed, or maybe it could be given at the end of one lecture or at the beginning of next lecture for the concept test. So finally, our tutorials and concept tests will help students acquire the useful knowledge by accounting for the cognitive issues in learning physics using a systematic approach. And it will keep students actively involved in learning process, and it emphasizes and rewards the development of the students' reasoning skills when they're learning the quantum mechanics. Okay, thank you very much.
We have time for 1 or 2 questions.
Okay, thank you very much.
I thought this was very interesting that because you did a control study, based on how the students learn. Because I see this with my son taking chemistry in high school, and it's the exercises and whether or not they can understand the exercises, than whether or not they actually get the concept of material in the well class. Yeah, very much the same thing you said.
So did you say you do this tutorial during the class meeting, so you meet in a computer lab and every student does it, or?
For the tutorial part, actually, it depends on different instructors.
Okay.
Sometimes, if they have enough time, or if they could find a computer lab, they can let the students individually run the simulation, learn the quiz in class. However, if there's not like a computer lab there, we could just let instructors